Good day, everyone. So today we are going to discuss about our lesson 2 in basic calculus. So lesson 2 is all about the limit of a function at C versus the value of the function at C. We need to study this lesson because critical to the study of limits is the understanding that the limit of the function f of x as x approaches C may be distinct from the value of the function at x is equal to c. To have a better understanding, we will mostly recall our discussion and examples in lesson 1. So, let us consider again example number 1 in lesson 1. So, we are going to find the limit of the function x plus 8 as x approaches 3. So from the tables of values, we can notice that from the left side of 3, as x approaches 3 from the left side, f of x approaches 11. And from the right side of 3, as x approaches 3 from the right side, f of x approaches 11. So therefore, the limit of x plus 8 as x approaches 3 equals 11. Now, we are going to find the value of the function as x equals 3. So that is, our function is x plus 8. So f of 3 is equal to 3 plus 8. Therefore, f of 3 is equal to 11. So as you notice, the limit of the function, which is 11, is equal to the value of the function as x equals 3, which is 11. Thus, the limit of the function f of x as x approaches 3 and f of 3 are equal. We proceed with our second example, which is limit of 1 plus 3x as x approaches 2. So from the tables of values, as x approaches 2 from the left side, f of x approaches 7. And from the right side table, as x approaches 2 from the right side, f of x approaches 7. So we therefore conclude that the limit of 1 plus 3x as x approaches 2 equals 7. Now we are going to find the value of the function 1 plus 3x as x equals 2, or that is f of 2. So our function is 1 plus 3x. F of 2 is equal to 1 plus 3 times 2. So we just substitute the value of 2 to the value of x. So that is f of 2 equals 7. So as you notice, again, from this example, that the limit of the function 1 plus 3x as x approaches 2 is equal to 7. And f of 2 is equal to 7. Therefore, the limit of the function f of x as x approaches 2 and the value of the function f of 2 are equal. For our third example, the limit of the function x squared plus 1 as x approaches negative 1. As you notice, from the left side of x as x approaches negative 1, f of x approaches 2. And from the right side table, as x approaches 1, from the right side, f of x approaches 2. Therefore, we conclude that the limit of x squared plus 1 as x approaches negative 1 equals 2. Again, we find the value of the function x squared plus 1 as x equals negative 1. So our function is x squared plus 1. f of negative 1 is equal to negative 1 squared plus 1. F of negative 1 is equal to 2. As you notice from the example, the limit of the function x squared plus 1 as x approaches negative 1 is equal to 2. And f of negative 1 is equal to 2. So therefore, we conclude that the limit of the function f of x as x approaches negative 1 and f of negative 1 are equal. So from those three examples, the limit of the function f of x as x approaches c and the value of the function at x equals c are all equal. Now, let's see our second example. The limit of f of x as x approaches 4 if the function x plus 1 if x is less than 4 and x minus 4 squared plus 3 if x is greater than or equal to 4. So we are going to use x plus 1 if x is less than 4. So from the left side of 4, as x approaches 4 from the left side, f of x approaches 5. And from the right side of 4, as x approaches 4, f of x approaches 3. So therefore, since from the left side, f of x approaches 5, and from the right side, f of x approaches 3, there are two values that f of x approaches. So, since the left side and the right side are not equal, we therefore conclude that the limit of the function f of x as x approaches 4 does not exist, or DNE. Now, we are going to find the value of the function as x is equal to 4. So that is f of x is equal to x minus 4 squared plus 3. So gagamitin natin yung function na x minus 4 squared plus 3 if x is equal to 4. So f of 4 is equal to 4 minus 4 squared plus 3. So therefore, f of 4 is equal to 3. So as you notice, that the limit of the function f of x as x approaches 4 does not exist while f of 4 is equal to 3. So therefore, the limit of the function f of x as x approaches 4 and f of 4 are not equal. So, we conclude that there are some situations that the limits of the function f of x may be distinct or may be different from the value of the function at x equals c. So, hindi sa lahat ng pagkakataon, ang limit ni function ay equal sa value ni function as x is equal to c. Now, we will review the graph given in lesson 1. So, from the graph, we can conclude that the limit of the function f of x as x approaches negative 2 is equal to 1 and f of 2 is equal to f of negative 2 is equal to 1. The limit of the function f of x as x approaches negative 2 is equal to 1. Kasi, kung mapapansin nyo dito sa graph, ina-approach ni graph si negative 2 from the left side at ina-approach ni graph from negative 2 from the right side si 1. So therefore, ang limit ni function as of f of x as x approaches negative 2 ay 1. While f of negative 2 is equal to 1 because kasi itong graph, kung mapapansin nyo, meron siyang bilog na black. And that bilog na black, yun ang ating value ni function kay negative 2. So which is 1. So therefore, f of negative 2 ay 1. Next, the limit of f of x as x approaches 0 equals 3, but f of 0 does not exist or is undefined. Now, hanapin natin si 0. So, ito si 0. So, from the graph, mapapansin natin from the left side, ina-approach ni f of x si 0 from the left side. Ina-approach ni f of x habang ina-approach ni f of x si 0 from the left side, at habang ina-approach ni f of x si 0 from the right side, ang value ni function ay 3. So, ang value ni f of x ay 3 or ang value ni y ay 3. So, therefore, yung limit ni f of x as x approaches 0 ay 3. But, f of 0 does not exist or undefined. Kasi, kung mapapansin nyo, dito, walang black or walang value or hindi shaded yung bilog dito. Unlike dito kanina na shaded yung bilog. Therefore, from the graph, undefined yung value ni f of 0. Now, dito, the limit of f of x as x approaches 3 does not exist. So, hanapin natin si 3. So, nandito si 3. So, kung mapapansin nyo, from the left side, habang ina-approach ni f of x si 3, ang value ni y ay 0. On the right side, habang ina-approach ni 3, habang ina-approach ni f of x, habang ina-approach si x, from the right side of 3, ang value ni y ay 4. So, dito, we have two values which is 0 at saka 4. So, kapag may two values, kapag hindi equal ang value sa left side at ang value sa right side, therefore, we conclude that the limit of f of x does not exist. Now, kanina, f of 3 also does not exist in the sense na hindi shaded yung dalawang bilog dito. Therefore, we conclude that f of 3 does not exist. So, malalaman natin ang limit ng function through graph kapag titignan natin kung anong value ang kanilang ina-approach. So, dito, sa negative 2, ang ina-approach nila, habang ina-approach nila si negative 2, ang value ni y ay 1. Dito naman, habang ina-approach nila si 0, ang value ni y ay 3. Dito naman, habang ina-approach nila si 3, dalawa ang value. So, therefore, does not exist yung limit. Pero, malalaman natin yung value ni function sa given c, gaya dito, f of negative 2, shaded siya kay 1, therefore, ang value niya ay negative 1. Dito, si 0, f of 0 does not exist kasi walang shade yung value ng function dito. Ganun din kay f of negative 3. So that's all for today. Thank you and God bless.